So this video goes along with page 3 where we're going to define what it is to be a proportion. So at the top here, what is a proportion? Well, it's when two ratios equal each other. I'm going to flip back real quick and remind you guys that from page 1, a ratio is simply a comparison of two amounts. Down here on the you try section, you went through and out of these 15 shapes, you compared circles to stars, squares to stars, all shapes, things like that. Now at the bottom of page 1, what we did was we actually used proportional reasoning to answer this kind of question. If we start out with 4 stars and then we go to 8 stars, we can see right here that the number of stars doubles from 4 to 8. So the number of circles is going to double to 14 circles. This is a proportion because 4 out of 7 is the same as 8 out of 14. These two fractions equal each other. Now, the next question, we went from 4 stars to 2 stars, so we cut it in half. So the number of squares will also get cut in half, and you can see that 4 over 4, which is 1, equals 2 over 2, which is also 1. So anytime two fractions equal each other, or two ratios equal each other, we have a proportion. On page 2, when you reduced all of these fractions, you essentially created a proportion. For example, 10/16 equaling 5/8, that is a proportion there in blue. We have one ratio set equal to another ratio. So now on page 3, how can we tell if two ratios are proportional? Well, what I've got here for you is an example of two fractions which are proportional. And then we've got an example of two ratios which are not proportional. And real quick, I'm just going to walk you through how we can determine whether or not two ratios are equal. One method is going to be to cross multiply. When we are comparing 2/5 to 16/5, if we cross multiply 2 and 15, we get 30. When we multiply 6 and 5, we also get 30. And since 30 equals 30, we know that these two fractions are proportional. Now with the 2/5 and the 8/15, when we cross multiply, we can see that 2 times 15 is 30. However, over here, 8 times 5 is actually 40. And since 30 doesn't equal 40, we would say no, these two ratios are not proportional. So one method would be to cross multiply and see what you get for the products. If they're the same product, then yes, they're proportional. If they're not the same product, then no, they're not proportional. Now another method would be to reduce both fractions. So when we go back to the 2/5, it's already reduced. Now let's reduce 6/15. The greatest common factor of 6 and 15 is 3. So if you divide this by 3, you get 2. And if you divide this by 3, you get 5. So 6/15 reduces, and when we reduce both fractions, we can see that 2/5 will reduce to 2/5. So yes, they are proportional. Now the other fraction, however, 8 and 15, it's already reduced, and we can see that 2/5 does not equal 8/15. The fractions aren't the same, so once again, no, they're not proportional. So far we've taken care of two strategies for how you can tell whether or not fractions are the same. For the third strategy, you could identify the scale factor. Here's what I mean for that. For 2, you multiply by 3 to get this 6, and 5 times 3 is also 15. So because they have the same scale factor of 3, you know they're proportional. Now for the other one, you'd have to multiply 2 by 4 to get 8, and you'd have to multiply 5 by 3 to get 15. So since you have different multipliers right there, with the 4 and the 3 are different, then no, they are not proportional. The fourth strategy I'd like to show you guys is to just convert the fractions to decimals and compare the decimals. So for 2/5, if you take that in the calculator and divide it, 2 divided by 5 is going to be 0.4. 6 divided by 15 is also 0.4. And since the fractions are the same, yes, they're proportional. Now over here, when we take the 2/5, 2/5 gets divided, still a 0.4. And over here, we're going to take 8 and divide it by the 15. And that's going to be a 0.53 with the 3's repeating. So since you get different decimals, then no, they're not proportional. So I've just walked you guys through 4 different strategies for how to tell whether or not two fractions would be equal. So down here, let's go through how to find which pairs of ratios would be equal. Personally, I'm going to cross multiply. I just think that that's a fast method. So for this first one, I'm going to cross multiply 2 times 10, that's 20. 4 times 5 is also 20, so I'm going to circle those as proportional. Also, again, you can reduce. Both of these reduce to a 2/5. When you divide, both of these are a 0.4. And you can see the same scale factor times 2 to get there, so this is proportional. Now for the second one, when we reduce the 4/8, we get a 1/2, and you guys know that 1/3 and 1/2 are not equal, so we will not select 1/3 and 4/8 as proportional. For 2 over 12, when we reduce that, that's 6. 2 divided by 12 is 6. 18 divided by 9 is 2. And 6 does not equal 2, so these two ratios are not proportional. 1/5 is a reduced fraction, and when we reduce 15/3, we get 5 over 1. So 1/5 and 5 over 1, they're actually inverses of each other. They're reciprocals, so they're definitely not equal to each other. Therefore, they're not proportional. For this next one, both of these are already reduced, and I will bust out the calculator to just verify. When you take 1 and divide it by 5, you get a 0.2. 5/8 is going to be a 0.625. So obviously not equal. Over here, I easily see that both of these can be reduced by 16 can be reduced by 4 to get 4. 20 divided by 4 is 5. So this reduces to 4/5. Therefore, these fractions are equal and proportional. And for the last one here, it's very easy to see that 3/6, that reduces to a 1/2. And you guys know that 12 is not half of 18. So this is not proportional. At this time, I would like you to please pause the video, and for the you try section, I'd like for you to now try to identify out of those multiple choice A, B, C, D, E, F, select all that apply that would be proportional. When you hit play, I'll reveal the ones that you should have selected. All right, let's take a look and see how you did. The ones that would be proportional are going to be A, D, and F. It's up to you. You could have cross-multiplied and verified. You could have reduced both fractions. You could have identified a scale factor, or you could have made them all decimals. For A, I easily see a scale factor times 2 and times 2. So since it's the same scale factor, boom, I know it's proportional. For D, I don't see an easy scale factor from left to right. However, I do know that right here, 3 times 14 is 42, and 5 times 14 is 70. I'm guessing you probably wouldn't have caught that. So for this one, if you cross multiply it, let's do 3 times 70. We get 210. Now let's do 42 times 5. Boom, we get 210. So if you cross multiply, you know we'll pick D, they're proportional. And for F, I actually just saw a scale factor of 5 times 3 is 15, and 9 times 3 is 27. You can reduce or you can divide. So 5 divided by 9 is the 0.5 repeating. Let's do 15 divided by 27. It's going to be the 0.5 repeating. All right? So you now have 4 strategies for how to tell if two ratios are proportional. And now for number 3, let's talk through how to find a select all given a ratio. So for number 3 here, I have given you the ratio of 1/3. And we're now going to select anything that would be proportional to 1/3. Well, 5/15 reduces to 1/3. So we're going to select that. 8/16 reduces to a half. So we're not going to pick that one. Now, 10 over 33, they're actually already reduced. 10 is an even number, but 33 only is divisible by 3 and 11 and 1 and 33. So it's already reduced, and obviously it's not equal to 1/3. Now over here, the 200 out of 600, I'm going to show y'all real quick with this strategy. You can actually cross out those zeros, and now 2/6 would reduce to 1/3. Just divide 2 by 2, done. Divide 6 by 2, done. You could have also, with that one, you could take 200 and just divide it by 200. So divided by 200 would be 1, and now 600 divided by 200 would be the 3. Okay? So that's proportional. And for the last one, 12 is 1/3 of 36. That reduces. And so we have 1, 2, 3 ratios here that we would have selected. We've selected the 5/15, the 200 out of 600, and the 12 to 36. Those are the 3 ratios that are proportional to 1/3. Now for the next one, we want to know which of the following is not proportional to 4/5. So for A, B, C, and D, you have 4 fractions, and one of them is not equal to 4/5. So down here, when you take the 36 over 45 and reduce it, you can reduce both of these by 9. 36 divided by 9 is 4. 45 divided by 9 is 5. So A is proportional. When you reduce B, 8 divided by 2 is 4. 10 divided by 2 is 5. So B is proportional. C is already reduced, and we can easily see that 2/5 is not equal to 4/5. C is a 0.4, and 4/5 over here would be 0.8. They are not equal to each other. So C is not proportional to 4/5. Now for D, when you take 12 and divide it by 3, you do get 4. And when you take 15 divided by 3, you do get 5. So 12/15 also reduces to 4/5, and it would be proportional. Now that we've reviewed how to determine whether or not 2 ratios are proportional, let's go through and start applying when we're going to be using these proportions and how we're going to be solving some proportions with an unknown. So up top now here on page 4, at a baseball game, 1 bottle of water costs $2. In the table of values, we can see that here, that if you buy 1 bottle of water, it costs $2. 3 bottles of water would cost $6. So now I want to know how much would 5 bottles cost. So here's the proportion that we're going to use to solve for this. Now a lot of you would easily be able to see it's just going to double, and you can see right there that we're going to fill in a 10 in the table of values. But I'd like to point out that right here, we're going to be learning how to set up a proportion, and we're going to be solving for an unknown. Now this problem's really easy, and so a lot of you can mentally see that if we're going from 1 bottle to 5 bottles, we're going to take the $2 and multiply it by 5 and fill that in with $10 right there. For the next question, I want to ask how much 8 bottles of water would cost. And again, a lot of you easily see in the chart that it's just going to follow the pattern. It's going to double from 8 bottles, $16. Right here you can see if we're going from 1 bottle to 8 bottles, the $2 is going to double, or triple, excuse me, not even double or triple. It's going to be multiplied by the 8 right here. So 1 times 8 down here, the 2 times the 8 is going to be $16. So we are going to be setting up proportions where we've got one ratio equal to another ratio, and one of them is going to be unknown, and we're going to be solving. We're going to be making predictions, other generalizations, and actually converting throughout the unit, and we're going to be setting these proportions up to do those things. Now down here, I'm going to walk you through the 2 methods. We've got 2 methods for solving a proportion when there's an unknown. First, before I teach you guys how to solve with method 1 and with method 2, I want to practice identifying a scale factor. Method 1 is going to be to identify a scale factor. First, let's practice identifying the scale factor. For 12/45 and 24/90, the scale factor would be 2, because 12 times 2 is 24, and 45 times 2 is 90. So that scale factor is 2. Now if you divide, folks, so like reducing, 40 divided by 5 is 8, and 35 divided by 5 is 7, your scale factor there is 1/5. Dividing by 5 is taking a 1/5. So scale factor for fraction, your scale factor is going to be a fraction if you're dividing. The reason that is, folks, is because by definition, a scale factor is something you multiply by. Okay? So right here, 12 times 2 gives me 24. And over here, 40 times 1/5 gives me 8. 35 times 1/5 gives me 7. Now over here, for the third one, I wanted to review that scale factors don't always go from left to right. You could spot a scale factor from numerator to denominator. So 8 times 3 to get the denominator, and 5 times 3 to get 15. And so right there, you can say that you found a scale factor of 3. Another division one, folks, 48 divided by 8 gives you 6. So dividing by 8 is the same as multiplying by 1/8. So anytime you recognize division where you're reducing, the scale factor is a fraction. Now let's use that skill of identifying a scale factor to solve when we have an unknown. So down here for number 1, we have a proportion where we're saying 6/11ths, and we want to know 6/11ths equals 18 out of what? Back on page 2, you filled in and reduced a fraction, and there's 4 numbers there. What we're basically doing now is pretending that we don't know one of the numbers. We don't know that number right there should be a 5. So we're going to say, well, 16 times a half is 8. So 10 times a half means that has to be a 5. That's what we're doing right now. So right here, 6 times 3 is 18. So you can just write down that the scale factor is 3. And then right here, you just got to do 11 times 3. And 11 times 3 is going to be that unknown of 33. For the next one, the scale factor, we can find it in the denominator. 9 times 5 is 45. So if the scale factor is 5, you just now got to do 2 times 5. 2 times 5 would be 10. Right, for the next one, in the denominator, we still have a scale factor of 5. 11 times 5 would be 55. So 4 times 5 is going to give me my numerator. X here has to be a 20. And for the last one, back to the numerator, we can see that 3 times 9 would be 27. So here, you just got to do 7 times 9 and get that X has to be a 63. All right? Now I want to go through how to check and make sure your answer is right. Let's go back to number 1. And for number 1, I want to remind you guys that we now said that this denominator should be a 33. So in your calculator, what you can do to verify that these fractions are equal, just take 6 and divide it by the 11. You've made it a decimal, and it's 0.545454. That's pretty memorable. Now let's do 18 divided by 33 and make sure we get the same decimal, and then we know that these two ratios are equal, and 33 is the right number to go in that spot. So 18 divided by 33, boom. Another thing you could do is cross multiply. This is again another strategy for making sure that these ratios are equal. So 6 times 33, that'd be 198. And now let me do 11 times 18. It's also 198. So these two fractions are equal, which means 33 was the right number. Obviously, you can check to see that times 3 is your scale factor, and 11 times 3 again should be the 33. All right, over here, let's cross multiply and check. 2 times 45 is 90, and we said that that X should be a 10, and 9 times 10 would be 90. So when you cross multiply, 90 does equal 90, so we know we're right. For this one, when we cross multiply, 4 times 55, 55 times the 4 would be 220. Now, if we said that this is a 20 right here, I'm going to multiply it by 11 and hope to get the same thing. So 20 times the 11, boom, we get the same thing, so you know that that was the right number to plug in. And so that's how you can check, folks. Just cross multiply with your number plugged in, and you should get the same cross product. So right there, 20 times 11 was the 220. And we already did 55 times 4 was 220. Boom, we're good to go. All right? Now down here, what we're going to do is review what you can do if you can't easily identify a scale factor. So method 2 up here, I had it already written down, is to cross multiply and divide. And so now down here, we're going to review how to cross multiply and divide. We know that 24 times 26, when you multiply that in the calculator, it's 624. And if these two fractions are supposed to be equal, then 14 times some number is supposed to equal that. So I'm just saying that 14 times A, that should equal 24 times 26. Now right here, you have a one-step equation with a coefficient. And to get rid of a coefficient, we're just going to divide both sides by the 14. 14 cancels out, and A is all by itself. Now in the calculator, when you divide 624 by 14, we're going to get a weird funky decimal. And if that ever happens, it's okay to totally just round. So right here, we're going to get a 44.6 when we round. Now let's try the next one. So we're saying from 3 to 5, I don't identify a scale factor, so you can cross multiply and divide. 3 times 15 is where I got the 45, and 5 times u should also equal 45. So 5 times what would equal the 45? Well, you're going to divide both sides by 5, and 45 divided by 5 would be 9. Now, I would like to point out that for that one, some of you might have said, wait a minute, I see a scale factor right there. So 5 times 3 is 15. So 3 times 3, boom, u is 9. All right, now for this next one, number 3, I think with the decimal and a negative, nobody's going to identify a scale factor very easily, so we're just going to cross multiply and divide. Bust out your calculator if you need to. You've got a 4 that's negative times your 7. That's where I got my negative 28. And then 2.8 times some number should equal that. So now you just got to divide that by 2.8. And boom, you're going to get a negative 10. Now, if we want to check this one, we're saying that that right there is a negative 10. So let's just make them decimals and see. Let's do the 2.8 over negative 4. 2.8 over the negative 4. This is a negative 0.7. So on this side, a 7 divided by the 10 that's negative, what do you know? It's the same decimal, so we know our answer is right. And now for the last one here, 4.2 times 5 in the calculator is where I'm getting this 21. And 8 times t is right here. I'm going to divide both sides by my coefficient, and now t is by itself. And 21 divided by 8 in the calculator is 2.625. Since that only goes to the 3 decimal places, we can easily just write that in our answer and box it. The first one, the decimal was a long, funky decimal and went on through the whole calculator, so we can just round it. But here, since it stopped in the calculator, it's fine. We can just go ahead and leave that there. And that concludes the video for pages 3 and 4. Thank you.